Alright class, before we get into complex rational fractions, we're going to review, because this is basically a complex rational fraction is basically a combination of an adding and subtracting and then a division. So, first thing, let's do an add. Again, to add or subtract, you need a common denominator. So this one needs an x plus 5, x plus 5. This one needs an x minus 2 and an x minus 2. Remember, you don't want to cancel anything. You want to actually multiply and add together on the top. The bottoms don't touch. So you get 3x minus 6 plus 4x plus 20 all over x minus 2 and x plus 5. And then you get 7x plus 14 over these things. And then finally, to check, you can see if you can factor the top. In this case, we actually can. However, it doesn't lead us to canceling anything. So, this would be the final answer. Okay. So that's adding. Subtracting works the same way. Division is like multiplication. You just flip the second piece. So, and then multiply. So let's do that. We still have x plus 5, x minus 6, a 3, an x, and an x plus 3, times an x plus 3, an x plus 1, all over an x minus 6. Let's look for our common factors that cancel. We have an x plus 3 here and here. We have an x minus 6 here and here. It looks like that's it. So we are left with a final answer of x plus 5, x plus 1, all over 3x. And this was the answer from the last one. Okay, so all we're doing today, again, is we are basically doing the same thing. Except for we have two things now. We have a fraction within a fraction, inception style. So you have to add the fractions together. Well, there's two methods actually. The first method is kind of like what we did up there, where we get a common denominator, push them together on top and bottom separately, and then flip and multiply the denominator to the numerator. Okay? The second method is multiply by the least common denominator of both the numerator and denominator and cancel. And I'll show you that for number 4. Okay, so number 3, we're going to treat these as two separate problems. This top problem, which is the numerator, we want a common factor. This one has a 3x, this has an x plus 2. So this one needs an x plus 2, and this one needs a 3x. Okay, so what this becomes is we get an x plus 2 on top minus 4 times 3x over 3x times x plus 2. And if you simplify that further, that's a minus 12 plus 1 is negative 11x plus 2 over 3x times x plus 2. So that's the numerator. Okay, now let's do the denominator. This one is an x plus 2, this one has an x, this one needs an x plus 2, this one needs an x. So the denominator becomes x squared plus x plus 2. Because this is an x squared, this is x plus 2, all over x times x plus 2. Two numbers that multiply to 2 that add to 1, nothing. That's it. So we have the denominator, we have the numerator. So now we're going to flip the denominator and multiply, because it's one big division. So we have the top is still negative 11x plus 2 over 3x times x plus 2 times, we flip this, the top is now x times an x plus 2, we could put these in parentheses if you want, over x squared plus x plus 2. Now we can cancel common factors. That's a common factor with that, that's a common factor with that, and that's all we have left. So we get our final answer is negative 11x plus 2 all over 3 times x squared plus x plus 2. So that is how you do a complex. It's basically two problems in one. That's method 1. Method 2 is figuring out what the LCD is of the whole problem. For example, if you look at number 4 here, we know that this bottom is x minus 5 and x plus 5. This one has an x plus 5, these have x plus 5s and x minus 5s, which means that the second method is to multiply the whole thing by the common denominator. So the top is going to get an x plus 5 and an x minus 5, and the bottom is also going to get multiplied by the LCD. And when you multiply these things, you're multiplying them to the tops of the fractions. So this goes to the 4 and the 2, this goes to the 1 and the 1. And what this looks like, I'm going to write it all out for you. So this piece goes here and here. So we're left with a 4, x plus 5, x minus 5, over, this is still just x plus 5 and x minus 5, plus 2. This also gets multiplied by both the x plus 5 and x minus 5, over x plus 5. And that's all over. These 1s are getting multiplied by this, so we have an x plus 5, x minus 5, all over x plus 5, plus, same thing, except for it's over an x minus 5. So here's what happens. Because we multiply by the LCD, all these mini fractions will cancel out and turn into just a fraction. So for example, in this piece here with the 4, both these go away, you're left with just 4. Here, you're left with a 2 times x minus 5. Here, you're left with an x minus 5. Here, you're left with an x plus 5. So what this turns into is the top just becomes 4 plus 2 times x minus 5, and the bottom becomes x minus 5 plus x plus 5, because there's no fractions anymore. And then you can simplify 4 plus 2x minus 10 over 2x, and that's it for that. So we get 2x minus 6 over 2x. Remember, you cannot cancel unless you could factor. We can take a 2 out of excuse me, on the top. Now we can cancel the 2. So our final answer is x minus 3 over x. And that works just as well as the first method. Excuse me. So let's try again method 1 versus method 2 for the same problem. Method 1, we need to do the numerator first. So I'll do the numerator here, which is this piece in purple. I have x over x minus 4 minus 1 over 4. This one needs a 4. This one needs an x minus 4. So this becomes 4 times x minus 4 on the bottom, and this becomes 4x minus, be careful with this, x minus 4. You have to distribute that. So we get 4x minus x is 3x plus 4. And there's the numerator. Okay. The denominator is a 9 over 4x, excuse me, plus x squared over x minus 4. So this one needs an x minus 4, and this one needs a 4x. So we get 9x minus 36 plus 4x cubed all over 4x times x minus 4. And we really can't simplify that. I'm just going to rewrite it so it's in correct order. Okay, so I have numerator divided by denominator, right? There's a division sign here. But when you divide this by this, you flip the second one and multiply. So now flip. So I get the first piece is still, the numerator just stays the way it is. Okay, and now we just cancel the pieces that need to cancel. So x minus 4's go away, the 4's go away. So we're left with the final answer of an x times a 3x plus 4 over 4x cubed, because nothing factors with this. And that's the final answer. Now we're going to do the same problem with method 2, which is finding the LCD. So let's see if we get the same thing. So again, to find the LCD, you have to look at all 4 pieces. We need an x minus 4, so for this method we need an LCD of, we need a piece of x minus 4, we need a 4, and we also need an x because of this piece right here has an x by itself. Okay, so we're going to multiply that as our LCD. So that means that that's what we're multiplying by. So we're going to multiply the top and the bottom by x minus 4 and then a 4x. And again, this is going to the tops only. And then we do the same thing for the bottom. And it goes to the tops. Okay. Remember, you don't want to actually multiply though. You want to leave it as factors. So here's what we end up with. On the top, we have this x being multiplied by an x minus 4 and then a 4x all over x minus 4 minus x minus 4, 4x, and you can think of it as 4 and x separate, divided by 4, all over, the bottom becomes 9 times x minus 4 times 4 and x over 4 and x, plus we have an x squared times x minus 4 times a 4x over x minus 4. So next step is cancel the individual fractions. These cancel. These 4's cancel. These 4x's cancel. And these x minus 4's cancel. Okay, so we are left with, on top, 4x times x. We'll have to do that now. At this stage you will find out, you will like multiply things out. The bottom is 9 times x minus 4 plus x squared times 4x. So we multiply the tops, we get 4x squared minus x squared plus 4x over 9x minus 36 plus 4x cubed, which already is our denominator we had earlier. So we get, what do we get? 3x squared plus 4x over 4x cubed plus 9x minus 36. And if you look at the answer, the only thing we have to do is factor the top. So we get, pull the x out, and we're left with 3x plus 4 over the denominator. And it does match from what we did earlier. So that's the second method. The second method, you don't really have to do the getting an LCD and pushing together. You can just cancel the LCDs out and then push them together. Okay, so you can use either method. I don't care, but that is how you simplify complex rational fractions.